The harvesting process is where bananas are collected with an optimal level of physiological maturity, which is achieved on average at 12 weeks of the onset of the inflorescence in the plant. The post-harvest process is where the banana is packed and distributed for calibration. In such a way that the most suitable for trade is selected. Did you know that, according to Minagri, the production of bananas by metric tons in Peru has increased almost 40 times from 2000 to 2013, being Piura one of the main producers. However, due to pest or disease, production efficiency can decrease at worst by up to 30%. For this reason, in automatic control systems course, we have considered solving this problem that affects thousands of Peruvian producers. To achieve this, we made use of artificial intelligence, specifically convolutional neural networks, which are a very useful type of neural network for image processing.
Did you know that the design of such networks is based on the process of human vision? This is possible thanks to the convolutional layers it presents, so that an image passes through the layers of the neural network and can be captured characteristics and patterns that differentiate the types of image. And thus, through the training process, the network can learn to classify the images with which it is being trained. In our case, a network was designed for the identification of 3 status: healthy with black sigatoka disease and bacterial with disease.
If the plant suffers from any of these diseases, early measures in line with the disease can be taken to minimize the economic losses of the producer. The architecture was inspired by that of the AlexNet neural network, as it's made up of convolutional layers followed by maps pooling layers, and ends with dense layers, where the last layer presents as many neurons as the classes to be classified. In the course of the neural network training, the K-fold cross-validation technique was used to determine the best hyperparameters, such as the number of convolutional layers, the number of convolutional layer filters, the number of neurons on the penultimate layer, among others.
The Adam optimizer was chosen to be used because it has an adaptive learning rate, with which it can be adapted to change in gradient descent. As a loss function, categorical cross entropy was used because it is discriminatory and can be used for multi-class classification. It was decided to compare 3 models. For the first one, any regularization technique will be applied. For the second one, dropout technique will be applied. And for the third one, weight regularization will be applied. In the final evaluation, each model had to classify 24 images, and it was obtained thus whose training was given with dropout and without regularization. Research an accuracy of 87.5%, while the model with weight regularization obtained an accuracy of 83.3%. Thus, it was possible to demonstrate the great capacity that this type of algorithms have and the repercussion that machine learning can generate in the agricultural sector of our country.